Okay, we're going to talk about heat and changes of state. Remember, you can say changes of state or phase changes. Either one of those means the same thing. So we're going to talk about, like, if you were sweating a bunch, what does that evaporation do when we have the liquid on your skin changing to a gas as a vapor? So we're going to talk about that in this section. So we're going to talk about heat diffusion and solidification. How does the quantity of heat absorbed by a melting solid compare to the quantity of heat released when the liquid solidifies? So we're talking about that solid-liquid phase change there in this section. So this is called the delta, we use delta HFUS, which means the molar heat of fusion. Heat absorbed by 1 mole of a solid substance as it melts to a liquid at a constant temperature. Molar heat of fusion, molar stands for 1 mole. Delta HFUS. Delta H solid is for heat loss when 1 mole of a liquid changes to a solid at a constant temperature. So delta HFUS, delta H solid are those molar heats. So for 1 mole. So these things are equivalent to each other because it's the same amount of energy to melt as it is to change from liquid to solid to fuse again. So these are exactly the same, and lots of times you'll just see this one used in both situations because it's the same number. So fusion can talk about fusing into a solid or into melting. It's just the opposite sign of it. So how could we do the delta H of fusion for a popsicle? So we have how many grams of that will melt with that many kilojoules of heat added to it. So this is the constant for fusion, and we have that many kilojoules was the given. We're not changing temperature because we're at a phase change, so we don't change temperature. And this is what's happening. We have solid. We're throwing that much heat in there, and we're turning it into a liquid. We want to find the number of moles of ice that can be melted by doing this. Okay, so we're going to have to change moles into grams so that we can do this problem. So we know that 1 mole of ice is that molar heat of fusion 6.01 because we were given that right there. But we have moles and they want grams, so we have to do a little converting now. And we also know that water is 2 H's and 1 O, so it's 18 grams for molar mass, mole, and grams. And so we're going to take our given heat, we're going to use that factor, we know, the delta HF fusion, and then we're going to change the mole of ice into grams of ice. So this is how we're going to use how we're going to find the mass using the delta H fusion. So make sure you can understand.